Hello. Yeah, good. So welcome to our game theory seminar. Today I have the big pleasure to have Yukio Koriyama, who was my colleague at the École Polytechnique for many years. So Yukio is undergraduate from the École Polytechnique in Paris. Then he did his PhD in economics in Chicago University with Roger Myerson, that you all know because you studied his paper to be admitted at the PhD program. He was his PhD advisor. And when he got the Nobel Prize, he had a meeting with Yukio, and all journalists were waiting to interview him. He didn't cancel his meeting with Yukio. He did the meeting, and then he talked to the journalist, just to let you understand how he's a big guy, Roger. And then Yukio came back to France as professor at the École Polytechnique when he was my colleague, and he is now professor of class exceptionnel. So he's an exceptional man, as you can see from his lecture to you this week. He's also, so we have some, I had the pleasure, so when I have lots of respect for Yukio. One thing I really want to thank him is when we finished our book, Majority Judgments, he was one of the first people who read it before it was published and give comments. And now he is translating the book to Japanese, and it's almost already done. And I'm very proud that my book is translated to Japanese. And the third contribution of Yukio is he's now applying majority judgment to participatory budgeting in Japan, which is also I'm proud of, and I'm very grateful for him to come here. And we proposed a subject together related to participatory budgeting and extension of majority judgment to multi-winner elections. So if some of you are interested, that's also one, you can choose it, we can talk about it. Now he's going to talk about something else unrelated to my work, and I'm happy for him to be here.
All right. Thank you, Rida, and thank you everybody being here. Well, that is too much that you have. Anyway, I'm very happy to be here, and so happy to have intense 15 hours that we have spent together, and then that was very much intense. So now I have one more hour, and then also I gave some introduction for today's topic. So students have some advance now that they know, they are familiar about this topic. Okay, so among other things that we have joint work. One of the things that I have been interested in for now years is about the collective decision making in the weighted voting. And then one of the things is about the US presidential election that influence our lives in many ways, actually. And then that I have been writing some papers about the problems of the US electoral college system. So as you know that many of the states in US electoral college system, they use the winner take all rule. That means that the result of the statewide popular vote, the electoral vote assigned to that state is all going to the state. So maybe without saying any explanation, it's easier to show that's just this picture. So this is a result of the 2024 US presidential election. So this is the electoral college system that you can see a lot of things from this just one picture. But as you know that the electoral college has this system that numbers are assigned, electoral votes are assigned to each state. From the biggest one, California, and then next Texas, Florida, New York, etc., up to the small states, which have the smallest number 3. There are 8 of them, if I remember. And then so all of the numbers, they go to the winner of the statewide election result, except 2 states. 2 states are the main use some different rule that the winner of the state takes 2 votes, and then all the rest is assigned according to the electoral district. Another is Nebraska. 2 of them also go to the winner, but the rest goes to the winner of each district. So here, there are many things that we can see, but this is the major example that we have in mind. But today, I'm going to talk about the decision making in this weighted voting, where the society is separated into the different groups, and then in each group that the voters may rule rules and that assign the electoral votes that is assigned to that state. So before I worked with my colleague about winner-take-all rule. We show that winner-take-all rule in weighted voting faces a structural social dilemma, in the sense that winner-take-all rule is a dominant strategy in each group, while the unique Nash equilibrium given by the dominant strategy is Pareto dominated. Okay, what I mean by dominant strategy, what I mean by the Pareto domination. Here, I think about this game as the state choosing the rule. So what is written in the US Constitution is that the number assigned to each state is the sum of the number of the senators and then sum of the number of the House of Representatives. So that's the one thing which is written. Another is that each state have the complete freedom to choose the rule how these numbers are allocated. So in the previous papers that we models this situation as a non-cooperative simultaneous game in which players are the states. And then states can choose the pure strategy, which is the function from the the statewide popular votes to the allocation of the electoral votes of that state. Okay, and then in that game, the players are the states, and then the pure strategy are the functions, and then the payoff is the utilitarian welfare of the citizens in that state, whether their preferred choice coincide with the final choice. Okay, so then if you are the governor of California, you want to maximize the utilitarian welfare of the California citizens, and then each citizen get +1 point if their preferred choice coincide with the final elected president. Yeah. So in this game, that the winner-take-all rule is a dominant strategy, because that whatever the result is, even 80%, 20%, or 51 versus 49, in order to maximize the expected payoff of your citizens, you put all the weight to the winners. Okay? Because in order to maximize the expected welfare, you push as much as possible of the expected payoff of the majority. Yeah.
The fact that it is actually ruled,
Mm-hmm.
the majority of states
Yeah.
are doing this,
Yeah.
was their decision
Yeah.
to do this?
Yeah. So actually the
Historically, it was like this.
That's right. So starting from the end of 18th century, 1776 it started, until 1832, more precisely, that the different rules has been used. And then 1832 is the first time that the winner-take-all rule started to be used. And the next election, 1836, majority of the state used. Since then, all the states are stuck. So that is the phenomena that maybe that the fact that this is a dominant strategy is a partial reason why we are stuck in this situation. And then we claim that this is Pareto dominated because there's a distortion coming from this step function. So the citizen's will is not reflected in the optimal way because there's a jump, so there's a huge noise around 50%. And then that is distorted. That's why in the certain states that that the swing states like Pennsylvania or Georgia or Nevada and Arizona and Wisconsin and Minnesota, and then these areas actually not Minnesota, Michigan. These swing states, it goes to either to the Republican or Democrats. It's changed the result completely.
But what you're saying, Pareto dominated? I'm confused.
Yeah, so Pareto dominated by the proportional profile. So this is the strategy profile that all the states use the winner-take-all rule. We claim that this is Pareto dominated in the sense of the expected payoff. Then another profile, if yeah, in all the states using the proportional rule.
It's a Pareto frontier, right?
Yeah, Pareto frontier actually.
Not maximizing the sum of the utility.
So that well, utilitarian sum, like if the constant is that the coefficient is 1, then that is 1 point, and then that is corresponding to the exact proportional rule. Yeah.
But if you use the proportional rule, it's implied that the vote is national in a sense, and you are just using majority rule.
Yeah, exactly. Yeah, exactly.
Because not precisely.
Yeah.
Not precisely because you have the weight of the state.
Yeah.
Number of senators, number of Republicans. It's not completely proportional.
Exactly. Exactly.
So you lose this.
Yeah.
It's
More or less. Yeah. Up to that discrepancy, that is exactly the intuition. So that is something that we see actually. So well, that these are the something that we consider. But then here, that the inconsistency is a national popular vote arises, like 2016, the famous case that Hillary Clinton won in the national popular vote, that Donald Trump was the winner. And then the 2000 case that Al Gore won the national popular vote, but George Bush was the winner. So there is some inconsistency, and then there are many reform proposals has been done. It is more than any other subject in the constitutional amendment, but then it have all failed. So some of the reasons why it failed is that there is no deviation that is consistent with the incentive. So no of the states that they have the deviation, even though they know that maybe possibly moving to the proportional rule may be Pareto improvement, that they don't have incentive to do so. So we need to have some coordination device. So that was a thing that I have been discussing in the past papers.
Sorry, can you repeat your last point? Why? I mean, it will maximize, electoral vote will maximize the sum of total utilities.
among all states, not inside your states.
All in the country, right?
Yeah, because inside your states, the dominant strategy for you is to do that.
So VTA is the best that you can do inside the state.
So yes, so assuming that the payoff of the state is to maximize the utilitarian welfare of that state.
That's a big assumption.
Oh yes, yes, yeah, that is a big assumption. So
because usually inside the state, depending on when, if it's Republican, you prefer to give the vote to the Republican, you see, the candidates. If Democrats control, you want to give it to Democrats candidates, whatever the votes are.
Yeah.
In principle.
Yeah, that's right. So
so how it comes that they still do that?
So yeah, many reform proposals have such aspect that everybody judge whether that is advantageous for them or not. Mm-hmm. And then that even that is another reason that why that the reform doesn't work. But also that in order to have even that commonly knowledgeable to have that moving to the proportional profile at the same time is Pareto improvement, and then it is beneficial for all states at the same time. But then it's like a prisoner's dilemma situation that there is no incentive to be sustained as an equilibrium. Okay, so that is the thing that we did before. Okay, so today, so that is something that we have been focusing about the winner-take-all rule. And not only the US electoral rule, but the European Union, instead of the European Parliament, that the European Council have such winner-take-all rule in the sense that that is a physical person who vote in the European Council. So you cannot split. So it's by definition, it is a winner-take-all rule, comparing to the European Parliament that the physical person that who vote for yes or no is different people, so it can be split. But then, so these are the examples, and then in the legislative assemblies, party discipline is often also is the winner-take-all rule, because all the members in the same party, they have to follow the party discipline, they have to vote in the same alternative. Okay, so that is these are the examples. But then that today's paper, actually I want to consider the orthogonal question to this Pareto dominance problem. So Pareto optimality is something that you can discuss in the, like what are the optimality in the sense of utilitarian, like you can see that even the, you can characterize all the Pareto frontier, but it doesn't say anything about inequality. So the orthogonal problem that we want to consider is what happens to the minorities. So what type of the rule favor the minorities, especially in the presence of the polarization. polarized preferences. Okay, so this is the type of the question I want to consider, and then this is a type of the exercise that I want to extend today. Yeah. Okay, so I go straight to the model, and I consider the case with n groups from 1 to n. You can imagine as these are the states. And then weights are exogenously given. So weight for 1, weight for n, W1 to Wn. And then I assume that there is no dictator state in the sense that no state have the weight more than the half of the entire sum of the weights. In that case, that's, the question is not interesting, so we don't assume that. Binary choice to be made in the society, so this is a limitation. So it's not a multi-party system. This is the case for the two-party system or the assembly voting for yes or no. So these are the binary decision making. This is what we are considering here. And we use the probabilistic model. And then each state I have the random variable theta I that takes a value between -1 and 1. That is a propensity of the group I representing the group-wise margin. Group-wise margin meaning that the margin in favor of +1 candidate. So there are +1 candidate and -1 candidate. Taking the value, +1 means that everybody vote for +1, -1 means that everybody votes for -1. And then that theta, for example, +0.2 means that the 60% favors +1 and the 40% favors -1. So the margin in favor of +1 is 0.6 minus 0.4, that is 0.2. So 0 means 50-50 split. And then the profile of the random variables that denotes the realization of the random variables. And then phi is the distribution where that this theta is drawn. Okay. And then the aggregation rule is a function from -1, 1 interval to the -1, 1 interval. And then the first one is the first one is the margin of the vote realization. And then the second one is the margin of the distribution allocation of the electoral votes. So 0 means that you split 54 for California into 27 and 27. +1 means you put everything to +1. And then this function, actually, if it is a 45-degree line, this is a proportional rule. And then if a state function taking -1 and then jump to +1, and that is a winner-take-all rule. So any non-decreasing function is can be chosen. And then the social decision is the weighted sum. So you can compute the sum, a weighted sum over all the electoral vote margin. And then if S of phi is positive, the final decision is +1. And then if S is negative, the final decision is -1. So that is how the social decision is made. So we focus on several benchmark cases. So one is the proportional rule. So for each I, phi of theta I is theta I. So this is a 45-degree line. And then in the case of winner-take-all rule, that is a step function that takes the sign of theta I. And then we focus on the symmetric profiles. So this is a limitation here. This is a statistical exercise that I go today. So we focus on the case that the theta I is same across all the states. So we don't consider the asymmetric profile. Okay, so now we want to study the normative comparison of the weight allocation rules with respect to the minority favoring. So in what type of the strategy profile, in light of the this rule profile, how the minority's opinion is more likely to be reflected to the social decision. So we want to have this structural property given by the nature of the function, either step function or proportional rule or something else. For that, we want to start with the ex-ante symmetry, following the Harsanyi's impartiality principle. So before making the decision that we don't know anything about the distribution, and then all the decision, all the evaluation is made at the ex-ante stage. And then to analyze the minority favoring, the minority should be well defined.
Symmetry means it's reflected with phi I equals phi, right?
No, phi I is phi means this is a proportional.
Phi I equals phi is not proportional. It means for all
Okay, phi I is...
symmetry, right?
Yeah, that is a symmetry, yes. Yeah, sorry, yes, that's right. But here, actually, we assume even more, something more, ex-ante symmetry of the theta I distribution in terms of plus 1 and minus 1. So we don't consider the situation that some states are known to be the blue states or red states. So ex-ante, that there are chances that some state can become blue or some states can become red, some can swing. But that distribution is asymmetrically distributed. So that is the symmetry we mean here. So to make the analysis meaningful, we have to define minority. But if ex-ante symmetric, there is no minority or majority. So then, one way that we proceed in this problem is to use the two-stage model. So in two-stage model, stage 0, everything is ex-ante symmetric. So the random variable not drawn yet. But then at the stage 0, that random variable profile is drawn from some ex-ante symmetric distribution guzai. Okay, and then there is a distribution. This is the distribution of distributions.
So this distribution or distribution, is it correlated or it's IID?
So this draw is IID. Okay.
So there is one distribution that I do IID for everything.
So that is the ex-ante distribution that each state is equally likely to be a swing or blue or red.
Is a distribution over minus 1, 1.
Say it again.
Theta is a distribution over minus 1, 1.
Exactly, yeah, exactly. So capital theta is a distribution. And then once this is drawn, now that you are in the situation that we know which state is blue, which state is red, which state is swing, and then the election happens. So theta is the election result. So theta I is the realization of the margin of that election. Okay? And then the winner A is determined by the weighted voting given the realization of small theta.
So just understand. First draw distributions, and then realization of the distribution.
Yeah.
How you draw from such a big space?
From
The space of all distributions.
The big theta.
So there is the ex-ante stage that we make the value judgment.
No, just physically. And, okay,
Ah.
so let's see. And I will see how you
Yeah.
Here's how you analyze.
Yukio, I have more of a conceptual, maybe framing question about minority favoring. Is it something that to you is a desirable property, or are you agnostic about it? Just how are we? Is it something we want, or?
Okay, yeah, that's a fair question. So I didn't say anything specifically yet, but to be honest, that I have the subjective judgment that the minority favoring is a good thing. But at this point, I didn't say anything, just to measure the likelihood that the minority favoring happens or not. So in this sense, that we can be agnostic.
The paper, the results of the paper do not depend on the answer to this question.
Right, and so that's right. The aim that we are going to the main theorem is giving the sufficient necessary condition, whether minority favoring happens or not. So in that sense, that we are neutral.
To answer your question, Olga, there is this famous tyranny of the majority principle, and usually majority rule is criticized because of minorities non-represented. And that's why many people, for example in France, the discussion is whether we should change the system to go to proportional representation, because in proportional representation all parties are represented, in particular the minorities. So it's a way to have them presented. It doesn't imply that they will decide, because then they should have been the majority group at the end. But this question is very important in political economy, as you know.
So that's in a kind of a probabilistic sense. We want them to sometimes have a say.
Mm-hmm.
Obviously not for
Yeah.
most of the time.
Yeah.
But it's about like
Exactly.
giving them a chance to
Yeah.
sometimes.
Yeah. So that's why we are really careful about the timing. So the judgment of the minority favoring is done at the interim stage. And then we study the interim probability that the minority favoring happens at the ex ante. And then the ex post minority favoring is ridiculous because it makes that you make the minority win. And then that means the majority loses. After the realization of the small theta, we are not considering the ex post minority favoring because it means that you just overturn the decision in favor of the minority. Okay, so that's a really important point. Yet, so you will see more. So here we distinguish the timing before this realization of theta distributions that we call ex ante, and then once theta i's are realized, but the small thetas are not realized, we call that interim, and then theta I, small theta i's are realized, we call that ex post, and then each stage ex ante expectation we write 0. And then for interim, we put the E1. And the probability also, we use 0 and 1 to signify ex ante and then interim.
But this slide still doesn't explain yet how you define minority favoring, right? It just explains the state.
Oh, yeah.
You will explain next.
It's the next slide, yeah. So definition of the minority alternatives is the expected loser at the national popular vote. So that means that so each time that once that the capital thetas are drawn, then we know what is the expected minority, expected the rate of the expected theta i's in the national-wise popular votes, and then the ones that have the lower value in the expectation at the interim, that is defined as minority. So there are two of them, so the smaller one. Oh, well, I mean that the +1 or -1, so that the
closest to 0 in each side.
so that there are two. It's a proportion. So that either +1 camp is expected to receive more than 50% or not. So if the +1 is expected to receive the more than 50%, the -1 is a minority. If it's less than 50%, then the +1 is a minority.
Sorry, but I thought you determined between stage 0 and 1.
Mm-hmm.
So now it's between 0 and 1, I have just the distribution of that in my state.
Yeah.
And probably you have average expectation.
Exactly, yeah.
Stage.
Exactly.
And if the expected winner is 1, so minority will
Yeah.
those if expectation is
Yeah.
negative.
So
Then the state is minority.
yeah, so for each +1 and -1, we can compute the ratio, right? Expected share of the vote. That is between 0 and 1. And then if it's higher than 1/2, then you are majority. And then
then you're majority.
Yeah. You are maybe thinking in terms of the.
Sure, 1/2 you have weights. That's why I'm confused.
So here, wait. So that may be easier to see. Okay. So the minority alternative is defined by the minus of the sign of the weighted average of this theta I.
Oh, I see. So you're talking about minority alternative, not minority state.
That's right. That's right. Yeah. Yeah. That's right. That's right. Sorry. That's maybe I was talking about California, and then so maybe that is a small state versus a big state. But here, minority candidate versus the majority candidate.
Oh, minority candidate.
Yeah. 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 So the minority alternative is either +1 or -1, and then so this theta is just normalized between -1 and +1. So the weighted sum determines expected amount of the total votes that +1 receives. And then if it is positive, -1 is the minority candidate. If it is negative, +1 is a minority candidate. And now the loser, yes. Expected loser. And then not ex post one. They may win ex post. Yeah. And then so minority favoring at the interim is defined in this way. So let A be the minority defined in this way. And then for any profile phi, we say that the phi favors minority at the interim with respect to the proportional rule if the interim probability that A wins under profile phi is higher than the probability that A wins under the proportional profile. So this is the comparison between the winning probability with respect to the proportional rule, that is we use as a benchmark symmetric profile. And then if the profile is a symmetric profile, uses phi everywhere, and then we compute the interim probability that the minority wins. If this is higher than the benchmark proportional case, we say that this rule favors minority at the interim stage. Finally, so that gives, like given the red state and then the blue state, and then we can say that, okay, winner-take-all rule is more likely to protect the minority or favor the minority. But this is not exactly the ultimate goal that we want to analyze, because ultimately, we want to see that ex ante without knowing what is a true distribution at the interim, so that, capital theta i's, we want to see that systematically whether some rule, winner-take-all rule or proportional, have some favor intrinsically to the minority favoring, and then that we want to measure by the by the probability that such a thing happening in the interim. We want to measure it by the ex ante probability that at the interim that the phi is more likely to favor minority. Okay, so that is a little bit twist in the, yeah.
I'm just confused with the second definition.
Okay. Second, you mean this one?
There can be many realizations of theta, right?
Yeah.
But you don't mention it here. Is it for any realization of theta?
So this probability is taking that theta as a random variable. Theta, you mean small theta?
No, capital theta.
Capital theta is a random variable here.
Yeah, small theta.
Small theta is random variable here.
But it's conditional on realization. Can you come back to the timing? So P1 is between stage 0 and 1, right?
No, 1 is after that capital theta 1 is realized. So,
right. So in sense, it's conditional on the realization of capital.
That's right, that's right.
But then your definition is conditional on the profile of realized theta.
Yeah, so it is.
For some theta it can be favoring, and for some theta it cannot.
That's right.
I see. So it's
that's right.
On the realization.
That's right. Yeah, that's right. That's right.
And
so
the other one unconditional.
Exactly. Yeah. So here that the expectation is taken over the capital theta i's, and then here, well, you're right that maybe I should write that it's conditional on the capital theta I, capital theta. Yeah. So this is a definition that we use. Oops. And then here is the theorem. So now we consider that there are enough number of the states. So this is asymptotic result. So with a finite n, the exact sufficient necessary condition is not easy to obtain. So we consider that there are sufficiently many states. In that case, that neutral rule profile, so neutral that I maybe skipped somewhere.
I'm sorry to come back. Can you stay?
Yeah, sorry, yeah.
Stage 0?
Yeah.
Can you come back? So how you draw distributions on stage 0? No, come back. When you have that, yeah. How you draw exante symmetric distributions. So can you give... So all possible, I mean, that's what confuses me. What does it mean?
So that...
can you define the space and how you draw the space? You can define it with CDF. CDF is any increasing continuous, I guess, functions.
Yeah.
And you consider distribution of all space of all symmetric continuous functions without any jumps.
Yeah.
But there is some distribution still.
Yeah. So that can be, that the easiest case, simplest case is that it has a finite support. So that Guzai have the finite support either to the blue state, swing state, or red state. In that case, that this Guzai tells us the probability distribution of the three possible thetas. And then given theta, we have the uncertainty. Yeah. Okay.
Not uniform, you don't, it's some specific, right?
Exactly.
Right.
So we use.
Also will matter for the you define for some it is and for okay.
Yeah. So I come to exactly to such exercise later. Yeah. Okay. So the neutral profile means that the profile is an odd function. So this function is symmetric with respect to a +1 and -1 as centered at 0. So this neutral profile phi is ex ante more likely to favor minority compared to the proportional rule. So that is ex ante. Neutral profile is this phi function that I thought that I wrote somewhere, but maybe I skipped. Sorry. So this function is an odd function here. So phi of theta is minus phi of minus theta.
Phi of theta is
right? So this is a function from -1 to 1 to -1 to 1, right? So here is the box, and then winner-take-all rule is a function that it takes -1 here and then takes +1 here. So this is winner-take-all rule. Proportional is the 45-degree line. And then any function that are non-decreasing, but we consider only the odd function. So symmetric, yeah. Yeah. So phi of theta is minus phi of minus theta. Yeah, so odd function, you can say. Yeah. I don't see the cap anymore. Sorry. Sorry. So that is the neutrality, what I mean. And then, so this is the main theorem. So for any neutral rule profile that the phi is symmetric, then it's ex ante more likely to favor minority compared to the proportional rule, if and only if this equation inequality holds. And then what is this inequality? That what matters is the ratio of the expected variance versus ratio of the variance of the expectation. Okay, so it's taking the variance in the expectation and the variance in the expectation in the opposite direction, and then the ratio between the proportional rule versus the phi rule, proportional rule versus the phi rule, and then putting some correlation parameter that is the correlation between the proportional expected value of theta I versus that expected value, interim value at of the rule after putting this rule phi. Okay, so this is the, this is the sufficient and necessary condition. Yeah.
Can you go over it when rho is 1, when it's proportional? I thought it should be equality. Is it equality when it's proportional?
When it is proportional, yes, because that these two things, everything is the same.
Oh, they're the same, and it will be more nice.
Yeah. And then that actually the correlation may be 1, even though this is not proportional. It is depending on the actually the distribution or even the support of theta i's. So I show the examples later. So here the intuition, it's a very straightforward actually in terms of the intuition. So let me call this average margin given this rule phi. Okay, that is a normalized aggregate margin. Sorry, I said average aggregate margin, in the sense that it's a sum over all the states, weighted sum, given the rule phi, and then you normalize with the square root of n because you imagine that we're gonna use the central limit theorem. And then under this profile, this is the average margin given this rule phi. So this example is given as the marginal mean aggregate margin for proportional rule, and then mean aggregate margin of the winner-take-all rule. Given this mean in the interim stage, that this is a case that without loss of generality, that the +1 is the majority. Mean aggregate margin is plus. That means that in expectation, +1 is likely to win. So -1 is likely to be a minority. In that case, that given this mean aggregate margin, so this is a random variable. And then as n goes to large, this it looks like a normal distribution. So this is a normal distribution of the aggregate margin for the proportional rule. And then for winner-take-all rule, this is also the random variable at the interim stage of the aggregate margin under winner-take-all rule. And then what is the area where the minority favoring happens? This is the area that minority wins, even though the expected majority is a +1, but the minority wins that the realization from this distribution happen to be minus. And then the comparison is that whether this black area versus the blue area, which one is larger. So in general, that the winner-take-all rule is a step function. Therefore, it tends to push the realization after phi is taken to the outside. Okay, because of this nature of the step function. Then that on average, that the winner-take-all rule result, that the aggregate margin tends to be farther from 0. But variance may be larger because of the noisiness, additional noisiness given by the step function. Okay, so when we think about asymptotics, n becomes large, and then we can imagine that these black and the blue, both lines converge to normal distribution. And then what matters is the sufficient statistics, that is average divided by the standard deviation. So this is really the sufficient statistics for the probability of the minority win. And then we call that d phi for each phi. And then phi favors the minority at the interim. That means that the -1 is a minority here. So, well, this is either -1 is minority and then DPR is higher than d phi, or +1 is minority and the DPR is less than d phi. In that case, that this area is larger for the case with phi with respect to proportional rule. And then that is same as that the DPR is positive and then DPR is bigger than d phi, or the opposite. And then we use the fact that asymptotically DPR and d phi are bivariate normal for large n. And then asymptotically these are the bivariate normal distribution. So then ex ante, both DPR and then d phi is 0. And then we have this covariance matrix. So then that we have this covariance matrix, which has just the two values, V1 and V2. These are the ratio that we saw in the theorem. Okay. So the above condition boils down to the ex ante probability that this happens is larger than 1/2. That means that the probability of that the interim probability that phi favors the minority with respect to the proportional rule is higher than 1/2 if this value is smaller than 1. Okay, so this is a purely statistical statement. And then we just write down, that this we put a square root and then like take a square, and then that becomes the exact condition in the theorem. Okay, so in the theorem that ratio is maybe a little looks like a complex. So I want to give some maybe the idea.
So I'm surprised that weights did not appear here in your weights disappear.
So weight is weight is in the aggregate margin. And then that, yeah, so
here weights are present, right? So
everything is symmetric, you
There
don't
comes
care
along.
about, you will put them inside.
In some sense, D matters to the weight, but somehow in a symptotic result, yeah. But I mean, I don't, yeah, I don't.
I think when you have many states, somehow it becomes.
So let me explain. Okay. So that this is a this is a linear in W in some sense, right? So this is a linear in W, and then the expectation is a linear in W.
Yes, but not the variance.
Well, variance is also in the linear order
But
because.
it's weighted, right?
Yeah, well, variance is it's in this as a random variable. This is a constant, and then this comes out, and then asymptotically as n goes to large, actually the effect of W, comes out like in the central limit term that the W square comes in the variance outside.
I thought it would be since all variances are the same, the variance going out, it will be square root of the sum of W's, right? There is a linear combination that sum, and here is always square root.
So
Maybe because the ratio what you care about, that's why when they are cancelled.
so actually, I think that I didn't really precisely say it, but this is asymptotic analysis.
Yes,
So then that there are a sequence of many states, and then each
how the weights then?
exactly. So Wi is drawn from some common distribution.
Oh,
Yeah. So there is a common distribution about the W, and then so once it is drawn many times, then in the limit that effect is equally arriving to the each state. So the coefficient coming to the variance, it enters as the W square constant, and then if you take the square root, that it becomes a multiple of W. So this W, order of W, and then order of W cancel out. That is the intuition behind it. Yeah. Okay, so well, the time is tight, right? So I think that how far I can go. How long?
I think you started a little later. So
Maybe.
let's say 15 minutes.
Okay, but maybe I don't even do too long. So let me give you some intuition with a very simple toy example. So assume that A is a parameter of the noisiness. So A is a constant between 0 and 1/2. And then suppose that ex ante, this is a bias that the capital theta I distribution may have. So this is that if this is a mean of the distribution theta I, and then this can take some interval, some value in the interval. So either it is biased to the right, maximum to the extent 1/2, or to the left in the extent minus 1/2. If mu is 0, it happens to be 0, then there is no bias. So the bias possibility is between uniformly between minus 1/2 and then plus 1/2. Then given that at the interim stage, that the capital theta I is a uniform between centered at the mu I, but the interval with the length 2a. Okay, so then this is a uniform distribution with a 2a, the same length. So it can be biased to the right, it can be to the left, but ex ante it is symmetric. So in this case, that the WTA, whether winner take all, most likely to more likely to favor minority than PR. So we want to compare these two ratios, right? And then here on the left one, that we can compute. Actually, this is a sign of this theta I. Is actually that something is a function of A, given that mu I realization. That the A is the parameter, and then if mu is close to A, then that interval is going to the almost either +1, always positive, or almost surely -1. So in that case, that the sign, variance of the sign tends to be 0, right? 1 minus alpha square divided by alpha square, this is 0. Because we are sure that this state is either plus 1 or minus 1. So variance becomes 0. So when some state tends to be biased to either to the right or left, then we have some sign, but what matters is the variance. And then if mu is happen to be a large number close to A, then this expectation of the variance becomes smaller. If mu is close to 0, so actually if it is 0, in that case this is a maximum variance because we don't know what would this swing state, it end up with the plus 1 or minus 1. And then with the winner-take-all rule, swing state, we don't know. This has the highest variance. And then the red state and the blue state, this has the lowest variance. And then it's, if you divide by the variance of the proportional rule, that is constant here. It doesn't depend on mu, because this is just a parallel movement of the same uniform distribution. So that is always a square divided by 3. So this is a constant, finally, 2 over a square. And then on the right-hand side, rho square times this thing. So now this we take the winner-take-all rule, and then we take what is the expected value of the plus 1 or minus 1 here. And then we consider how variable this expectation is. So then that actually is constant, because now whatever happens, that the expected value that you receive in after this, either plus 1 or minus 1, expected value of this plus 1 minus 1, the sign of theta I, is constant. It doesn't depend because this is a parallel movement. And then rho, in this case, this is even, theta is a constant, is a the uniform distribution over the interval. The correlation between the expected value of theta and the expected value of sine I, it changes perfectly in the perfectly correlated way. So the rho is 1. And then this is also the same at a square over 3. So we can compute that. It is 1 over a square. So the left-hand side is bigger. So in this case, that winner-take-all rule is without ambiguity that ex ante more likely to favor minority than proportional rule. So this is the case that actually very baseline uniform case. Actually, the intuition behind it is that under uniform distribution, the winner-take-all rule makes a noisier result, and then it increases the surprise win. Therefore, at the interim stage, it's more likely to give more favor to the minority because it adds more noise, and then the surprise win is more likely. So that is a rough intuition behind the simplest case of uniform distribution.
That's surprising, right? In some sense, it's not what would you expect. Right?
I thought the opposite.
Yeah. So.
What's the common wisdom?
I think this goes again. So R is Pareto optimal. So you want some cases where WTA is better if you think that minority should.
So that is maybe one step further. I agree, both of you actually, because I don't know what is natural anymore because I thought about this many times. But here, very simple intuition is that there is no known bias, right? So that the bias could be either plus or minus. So this, uniform is there's some additional bias. And then given the bias, that the uniform distribution is exactly the same. It is just the difference is that a parallel movement from right or left. So in terms of the variance, expected value, there is just a parallel move. In that case, that what happens is that, okay, the realization of theta moves on this axis, right? In the winner-take-all rule, the result is more noisy. And the proportional rule, this is a 45-degree line. You don't see anymore, but a 45-degree line here. Then that it moves, that actually the variance or the, how the statistically this distribution look like doesn't change. It's just a parallel movement. So the proportional rule is less noisy. The additional noise given by the winner-take-all rule gives more favor in terms of the surprise win of the minority.
Do you understand intuition correctly? Just larger variance, right? Whatever has a larger variance and noise will kind of favor minority. Of course, it's very rude intuition.
Yeah.
To have a precise formula.
Yeah, yeah.
Because this is binary
Yeah.
situation. Now
Yeah.
I expect
Yeah.
Republicans.
Yeah.
But if there is a more noisy room,
Yeah.
then of course,
Yeah.
with higher probability, actually Democrats will win.
Yeah.
Which minority according to you.
Yeah, yeah.
But that basically defines the variance of the rule.
Yeah.
Right? Okay.
Yeah, and then that actually the theorem says it's a little bit more complex. So that is also the step that I was thinking.
No, it was very simplistic. You think
Yeah.
much more.
So then that I think it's helpful to see the next example. So in the case of polarization, actually that this which type of the bias is given in the favor of which camp, that is actually not that clear. And then this is the simplest example again, that you can see that there are three types of interim marginal distributions, so that ex ante, nobody knows that each state becomes either right wing or left wing or swing. But there are three possibilities. And then, so to keep the symmetry, that swing is symmetric around 0, and then right distribution is exactly the opposite of the left distribution. Okay, so this is a completely symmetric case. And then ex ante stage, there is some parameter probability P. With probability P, the state can be either left or right. And then with probability 1 minus 2P, the state is swing. So this is a completely symmetric distribution ex ante. So Xi have the three support with the probability PP and the 1 minus 2P. So then that before drawing from Xi, that state can be swing or right or left. Okay. Then assume further that they have the same variance. So that imagine that theta right or theta left. This can be not anything. It can be uniform or something like a different. But assume that they have the same shape, and then just moving to the right or left. And especially, it is sufficient to assume that the variance is the same. Variance of the left distribution, right distribution, swing distribution, this is the same. And then now, expected value, the mean of the swing, is this is because that we assume this is symmetric around 0. The expected value of this swing is 0. But also, if we put a sign after the winner-take-all rule, that is, we assume that's 0. It's a completely symmetric distribution. On the other hand, that the mean of the right distribution is exactly the opposite of the mean of the left distribution, and then we call that is mu. And then the sign of the right distribution, that is put to the right or left. Now, actually, that this is a right, so the red state. Then this has some value. This is exactly the opposite of this expected value, and then that we assume that mu prime.
And just to make sure I understand, mu prime should be greater than mu, right?
So here that so it yeah. So let me see. So it depends. So actually, that it can be either bigger or smaller, but then that okay. So not.
Explain how mu prime can be smaller. After its sign, it has been minus 1 or 1. It is a level intermediate, but the range is larger. And,
It depends on the shape of this curve, because the curve can be something here, right? So in the left distribution here, and then that all the negative value is pushed to the left. And then if there is some part coming to the right, it's pushed to the right. So if this is, the curve is concentrated in the middle, then the push is larger.
oh, it depends, you mean, on the theta, but theta is not support of the theta between minus 1, 1. It can be larger or smaller, right?
Right.
Larger or smaller, that's the reason. Because I thought it's instead of theta, now I have plus 1 or minus 1. If all the thetas are between 0 and 1, sign is just...
Yeah. In that case, but we don't assume that.
But here you don't have...
We don't assume. It's just yeah. But good. So now that makes understanding even further. So that's great. So now that intrinsically we don't know that whether mu and the mu prime which one is bigger, and then here that the E0 of variance of theta I is constant by definition, right? That we assume that, right? We assume that. Okay, and then rho is 1 as well because that the order right or left, and then like in the middle, that the expected value of theta itself is either right or left. Then the sign that you take is either left or right. That is perfectly correlated. So rho is 1. And then we can compute that the variance of mean of theta I is 2p times mu square, and then variance of the sign of expectation of the sign is 2p times mu prime square. That is, straightforward. Then that this condition that we want to verify, the E0 of variance of theta I is constant, and then rho is 1, and then this is that what we saw in the previous slide. So what matters is that E0 of the variance of the sign of this theta I. So this decreases as P increases, because P increases that the ex ante, this society is more likely to be polarized. So now that the winner take all, the magnifying effect decreases. Because now that we know ex ante that the society could be either polarized here or here, more likely. In that case, that the winner take all pushes to the end, but this magnifying the error effect decreases because that we know that already it's likely that this state either really strong red or strong blue. Okay. In that case, that to the contrary, that the society becomes more swing, so P decreases, then it's more likely that all states is more likely to be a swing. In that case, that the winner take all's effect of this discontinuity increases the variance of the result. So the variance becomes more random. Variance is higher, and the result becomes more random. As a result, that we can show in this specific case, we have the closed form solution that if P is higher than this specific threshold, then to the contrary, that the proportional rule now almost surely favors minority compared to the winner take all profile. So in the polarized situation, the minority favoring function of the winner take all rule is lost. Okay, so that is one of the things that you can see.
Do you have the opposite result? Sufficient condition when WTA is favors minority more than here?
Yeah. So that is yeah. Yeah, that is a sufficient and necessary condition. Yeah. So we can go for some cases that if there is a hole here, like so the mu tends to be either it takes a value either minus or plus, and then never takes some medium, and then the mean is same as the first example. In that case, also we can get some closed form solution as well, meaning that if the hole is big, then winner take all tends to lose the function of favoring the minority. Okay, so continuous case that there are many extensions that you can consider, but let me go to close to the conclusion. So here, the cases that we verified that the uniform distribution case, that the first example, and then truncated normal is the case that instead of uniform, that we put normal, but the normal we cannot do with the entire support because this should be truncated. Okay, so instead of uniform, we don't need to worry about the boundary, but now we consider the truncated normal. And that is the case of the red line. And then the polarized erection, that is something that we put P and then P, and then 1 minus 2P. So all cases, we can verify that how many number of the groups, how many groups are necessary to get this asymptotic result. So N is large, that is what we assume. And then for each case, the blue case, the ex ante probability that the winner take all favors minority is 1. And then this blue line, as the number of groups N becomes from 5, 10 to 30, then it approaches to 1 relatively reasonably. And then the polarized case that we saw that the theoretical value is 0. And then this converges fairly well. And then the truncated normal case that we can compute the theoretical value as the n goes to infinity, that is a pink line. And then for the finite case, it also converges in the relatively quickly. So that is a sensitivity check that we did for the case with different number of the groups. So all the analysis we gave is the asymptotic that we consider n goes to infinity. But we verified that it's not that far from the case with a reasonable number of the states. Okay, so some extensions that we have in the paper includes the costly voting. So there are some cases that we consider that the voting has the the voter have to pay the cost to go to cast a vote. In that case, that the minority favoring by winner-take-all is reinforced by the endogenous voting because there is an underdog effect. So that someone that you are so that if you are voters, that you expect that your supporting candidate is tend to lose, then you have more incentive to vote. In that case, but that is called underdog effect, right? So in the case of costly voting, such endogenous decision of going to the vote raises the turnout rate of the minority, and then it reinforces the function that the winner-take-all rule tends to favor the minority. So that is extended with the entire section. And then the numerical check that we give. And then we described such minority favoring as the statistical gerrymandering. That means that some packing goes on due to this step function of the winner-take-all rule. So we provide some intuition that this type of the packing, this type of the statistical feature given by the winner-take-all rule can be understood as the not intentional gerrymandering, but it's like a statistical gerrymandering given by the function itself.
Can you explain that? So now what we observe is that there are little number of swing states.
Yeah.
And the big number of non-swing states. And this, so as if
Okay.
If you have full gerrymandering, then you will
Yeah.
have
Okay.
only non-swing states at all.
Okay.
But you have few number of swing states.
Yeah.
It is like kind of gerrymandering.
Yeah.
The turnover is very small.
Yeah.
And depend only on the small number.
Right.
That's the intuition.
Well, the intuition is that with the winner-take-all rule, actually that it gives to the push to the end, either +1 or -1. Even in the swing state, there are small chance that the minority wins. So by pushing, that is making the voting result close to +1 or -1. And the +1 is a big waste in terms of gerrymandering. Because if you have the support, but then all you need is a 50 plus epsilon. So anything after the vote that you receive in the winning state is a waste. So by putting the winner-take-all rule, that actually it pushes to the wasted vote, it increases the wasted vote, while that in the polarized case that doesn't come to the case to the big loss. Big loss is advantageous on the other hand, because if you lose with 0%, you don't waste any because you lose anyway. You lose in the 49% is bad. So there's an asymmetry that the 0 is good, 49 is bad, 51 is good, and then 100 is good. So then the winner-take-all gives this, that the packing to the case, and if we polarize that, you lose a lot. Okay, so that is gerrymandering interpretation of this result. Okay, so let me conclude. So this is a statistical exercise that we did, the welfare consequence of the winner-take-all rule, a dilemma that WTA is dominant, and then this fact itself, Pareto dominated, do not speak to the minority favoring. So this is about, the previous result was about the Pareto dominance. But here, this exercise that we try to understand more by using this two-stage model, two-stage formulation, to highlight what is a key factor, that is the comparison between the ex-ante variance of expectation versus the expectation of the variance. So this ratio is the key factor. And then the minority favoring can be interpreted as a surprise win by the proportional loser. So that is the interim minority. And then the greater electoral noise tends to benefit the minority, under which winner-take-all rule generally performs well. However, there are some exception cases that the polarized society, winner-take-all rule, this advantage that this is my value judgment, advantage of favoring minority may be reduced. It doesn't work in the polarized society.
It is though polarized in this particular model, right?
Mm-hmm, mm-hmm.
Because you could model polarization.
Yes, yeah.
Example, for example,
Totally. Yeah, totally, you're right. And then I use a little bit rough way of using polarization. Of course, now the polarizations have a lot of different aspects, and then very specific way we can show that that in this meaning polarization helps to have this proportional rule to tend to favor minority, and then this happens because of this that polarized society, that you have less variance of the result. When the society is polarized, that the result more or less, right? So in that case, that the variance of the expectation goes down. So that works in general. So that is more general than the specific case that we discussed. Yeah.
And can you say something about electoral college?
Mm-hmm.
In which case are we? Because here, as election after election,
yeah,
it's not like if each time we draw at random something, because the swing state remains.
Yeah, that's true. Yeah. Mm-hmm.
So do you have a model of this? Can you say something about the actual situation?
That's
inertia somehow, and there are a few number of swing states.
Yeah.
And a large number of non-swing states.
Yeah. That is a question difficult to answer, I admit. But actually, that kind of the analysis is completely complementary to this analysis. This analysis aims to give the normative aspect without knowing the true distribution, without specifying the distribution. So this is really the behind the veil of ignorance, that the Harsanyi type of the impartiality analysis, to reveal the property of the function itself, aggregation function, proportional winner-take-all rule, or etc., to see whether this is really the structural property that is given without knowing which state is blue, red, or swing.
Yeah, this I understand. But now, if you want to discuss the actual situation,
yeah,
is it a way to model it?
Yeah.
Differently, is it making sense? Even
Yeah.
the question, because I imagine that the reason of electoral college is
Yeah.
to somehow,
Mm-hmm.
in particular, because we give two senators.
Yeah, exactly.
To
Yeah.
all states.
That's right.
Of the number of population.
That's right.
It gives more weight to
Yeah.
small states.
That's right. Yeah.
compared to
That's right.
states.
That's right.
So this is already in the numbers we give.
Yeah.
And you add to this
Mm-hmm.
the rule fee.
Yeah.
And in the mind of the people who write this constitution, of
Yeah.
they wanted
Yeah.
small state to have
Yeah.
more something to say,
Yeah.
because they don't want to have this tyranny of the majority.
Yeah.
In the sense that I am a small state.
Yeah.
I say nothing almost on,
Yeah.
on the final decision.
Yeah.
So now, if we come back to this debate, can you
Yeah.
say something from the paper?
So actually, not from this paper, but from another paper, I have exact statement about it.
Mm-hmm.
Actually, that instead of the winner-take-all rule versus a proportional rule, the two states you remember that uses a different rule, that is Maine and Nebraska. That tells us that is a linear combination between the winner-take-all rule and the proportional, in the sense that the 2 goes to the winner, and then the rest goes to the proportional, distributed proportionally. Then, if all the states use this rule, then that the 2 goes to the winner, and then all the rest goes to the proportionally. That goes to that direction, and then that actually reduces the inequality and then works in favor of the smaller states, Why? Because that the small state like Wyoming, they have 3. And the 2 goes to the winner-take-all rule. So this rule is very close to the winner-take-all rule. California, 54. 2 goes to winner-take-all rule, but the 52 is proportional. So the big state uses the Pareto dominant, not strategic dominant strategy, but the smaller state is using the strategy which is close to the strategically dominant strategy. So that gives a systematically favor to the smaller states. So that answers to that concern.
Can you analyze it here?
Well, here we use that the theta, the phi is symmetric.
Yeah, because you have this WI also.
Yeah, exactly. Yeah, so this itself cannot be integrated by itself. Yeah, but that is a good question. Yeah, that is how to combine. That is really interesting.
WI plus 2.
Yeah, exactly.
And WI is taken at random, but you have these 2 additional, small, big.
Yeah.
But I mean, related to this question, whether you compare, I'm afraid many things depend on the exact distribution, ex-ante distribution, right? So if you think it to bring it to the data, it will be probably. I understand how to calculate the interim variance, but exact variance would be very hard to back up from the data.
So that is a challenging task. I think that our modest contribution is to reveal that there is a systematic direction that the winner-take-all rule and the proportional rule favors minority. That we show the direction, not exact impact. Maybe that it's hard to use literally this model.
Or maybe you know how to do it. I just know. Is it possible, like if you have the data on all elections, how to even think about ex-ante distribute? I just don't know how.
Yeah. That is difficult to imagine. That So now we are in this world, so we have already some distribution already. So going back completely to the symmetric ex-ante, that is only done by the thought experiments.
Well, maybe now it's my econometrician. Then I'm thinking how I would identify that.
Maybe you're right, but I'm not good at it.
A question from our student.
Yeah.
You can ask any question you want, in particular related to his lecture.
I translate. You have to ask the question.
Yeah, anything? Tell me. Yeah.
There is no mechanism right now that favors the minority.
So this is not really, there is no strategy. This is a purely statistical exercise. Yeah. So there is no mechanism design in this study itself. So this is to reveal the statistical structure related to the winner-take-all rule and the proportional rule. So previous papers have this strategic interaction, and then what is that? Well, in some sense, that there's a design problem that what rule is preferable to have the more equal or less minority suffering. So that is, in large sense, that answer to the design problem. Yeah. Good.
Thank you.
All right, thank you.